Obviously, when you have a differences, you compute something based on the independent data. So how we will do this type of calculation? So independent data. So there is an equation, just a normal equation. There is something on right hand, left hand, but that equation involving differences or a change of a discrete data set. What does this mean? For example, but before to go to that definition and existing, we will discuss further based on the time that we have for this lecture. I want to point out one some conventions that we will use here, so that it will very easy to discuss further topics in a difference equation. So, for example, I have this data uh, of independent variable. So this is the value of the data x, and if I have a data discrete, so there is some separation between the data by the amount of h, for example, and that data is obviously at a distance of h unit. Similarly, if this is the data point, so it is with reference to this data situated at 2 units from this of h, and similarly x plus 3 h and so on. Similarly, if we are here, we will have x minus h, which is the back of this data with reference point, x minus 2 units back of it, and x minus 3 units back of it, and similarly this continues. So we have done this ahead as well, and similarly we can have some y values as well, which we are not highlighting at the moment, but we will do it in a later stage. So x is there. So what I want to do, I want to introduce some convention there. So what I want to say, rather than just saying x here, I want to represent it with a symbol, a subscript notation. Is like that, x is there, and then there is a subscript notation I. So what does this mean? This means that if I am referring to xi, so let's say this is the variable xi, index xi. So any value which is ahead of it has a value x plus h, and the symbol that I will use for that value is xi plus h. What does this mean? This means that this is the reference value, and the value, this value is 1 unit of h ahead of it. I mean this value. Similarly, if I write down x I plus 2, so this means that this is the reference value, this value, and I'm talking about this value, that is a value which is 2 units of h ahead of it, I plus 2. And similarly, I can say I plus 3. So I plus 3 means this is the value of this value which has this magnitude, and that value is situated 3 units ahead of h value. So that's the main point. Okay, so here you have noted I am not introducing or writing anything with h. I'm just indexing them. These are the magnitudes of the values, and this is just their index. Similarly, if I am here, so you have a pattern now. So tell me what should be the index here. Is it this index? We are at ith unit, but we have moved 1 unit backward. So when we move backward, we say I minus 1. So we can say this is the reference value. So this is his right hand value. This is his left hand value. Similar to this one. This is the right hand value. This is the left hand value. And if I move 2 units left, so I will have obviously I minus 2, and similarly I minus 3, and so on. There are many values that we can define. So these all are the values on a line, but they are defined accordingly. If these are the x coordinates or an independent variable, so similarly what we can have, which I already told you we will define later stage, if this is the point x, so it must have some value y on ahead. If this is the point, this one, So it some have some value y as well. So how to distinguish these two values? So what we are doing, we are using this convention. So what we are saying, if this is the value x has a value y, so we will make it like that. We will label it xi. We call it xi. So the any value which is ahead of it based on this variable x value, so I will call it xi plus 1. And similarly, any value which is on the back of that reference value, yi minus 1, sorry, x, this means y. So what I want to say, these are the independent values all, and the dependent value, that is y values corresponding to that data, is also labeled like that. yi plus 1, yi plus 2, yi plus 3, and so on. And these are on the back side, yi minus 1, yi minus 2, yi minus 3, and so on. So this is the reference values, this is independent, and this is dependent y values. So with reference to the last example that we have solved, this is your time, these values are time, and this is your temperature. So I have to write down accordingly. So if we want to write down, then I can say like that: time Ti, then the temperature at that time is T, small ti. So this is the value that we. So if we have computed all the quantities, so what we have done here, so what we have done, we are not dealing with the magnitudes, we have introduced indexes. So I am not interested what is the value of this L. If I want to compute, I can do it by adding H amount. So I will get there. But whatever be the value here, I am saying it as xi plus 1. So I could be any value. If I is here, then this becomes I minus 1, and this becomes I plus 1. So there is always a pair of values like this. If this is ith index, then the other value is I plus 1 on his right hand side. On his left hand side is I minus 1. Similarly, 2 units I plus 2, 2 units I minus 2. I hope I have made my point clear to you. So if any one of you wants to take break, in fact we are ending the lecture. We are very close to end the lecture. So we can, I hope this convention is clear to you. So it is just values, rather than using the magnitudes of the values, we are just giving the labels: xi plus 1, xi minus 1. Okay, so this is clear to you. So let's think about it. Let's think about it. What does this means now? So if you remember, today I have computed a very simple difference operator like this. Not today, in last lecture we defined it. In today's lecture we just use that operator, forward difference, for second order. So if you remember, for second order, d of x based on forward difference could be defined like that: f of x plus 2h minus 2 times of f of x plus h plus f of x, and this whole quantity is divided by 2 times of h. Keep in mind, I am dealing a concept of derivatives and forward difference. So you remember all this thing? Okay. So based on the convention that I have defined here, so I can clearly see that this quantity f of x plus 2h is basically a value that is can be represented as yi plus 2. Why? Because I want to read the function f at what point x plus 2h. So if I go back, if this is the x is a reference value, then x plus 2h is this value. So if I want to read the function there, so I have to use a label yi plus 2. So what I can do here, I can say in my new convention, this thing, this term only is equal to yi plus 2 minus, keep in mind this is subscript, these are in subscript. This is the variable and this is written in a subscript. You can write down accordingly. Now student, similarly You all know what would be the value of f of x plus h. Let's go back again. If this is the x, then x plus h is this quantity. If this is the x plus h quantity, which means that the value of the function, vertical values of the function, that is y values, is in this case is yi plus 1. So what I can write down instead of it 2 times of yi plus 1. Again, this is subscript, this is multiplying that quantity. Okay, and similarly I do not need to go back, you all understand this quantity would be the yi, because we are dealing with reference to the x values. And similarly this whole quantity is divided by 2h. Okay, now straight y, and this whole is equal to 2 times of functions evaluated at yi. So now everything is replaced with yi. So what I'm saying, if I want to compute second order derivative of the yi quantity at the ixi point, so that second order derivative is defined according to this convention, according to a new convention. Similar, they are similar magnitude wise, everything is similar. We have just used a different symbols, yi plus 2 in subscript, and this is in a subscript. So what does this has to do with our topic difference equation? Suddenly, why all this thing has to be discussed? So the reason is this quantity is very important for us now, because if I say, let's say if I say to you that the second order derivative of derivative second order derivative is is constant. For example, we are dealing with the data whose second order derivative is constant, for example. So this means that this is the second order derivative of the quantity. So whenever I compute the second order derivative of this quantity based on forward difference approximation, so this has to be constant. So whatever this second order derivative I am computing, it must be constant. So let's say the constant has a value, let's say a, for example. So what I can write down mathematically, yi plus 2 of that data whose second order derivative is constant is like that, yi plus 1 plus yi divided by 2 times of h. This is the second order derivative, and that derivative, as per the according to our new advice, this is constant. So let's say the constant value is a here. So I have write down this quantity again. So there is some data which is represented as yi plus 1, yi plus 2, and similarly on negative scale. But that data has a behavior that second order derivative is constant. So according to our operators, the second order could be written like this based on forward approximation. And if this is true, then this and it's constant. So this is the expression that we have, this equation that we have represented in a box. So if I try to solve it a little bit, so what I can have here, yi plus 2 minus 2 times of yi plus 1 plus yi equal to 2he. What I have done, I take this 2h towards the right hand side, because if the data is given, then h is also constant, so we can do that. So student, here whatever we got here, this is the whole quantity, is basically called this what is representing is called difference equation. What is representing to us is difference equation. Why it is representing a difference equation? Because these three quantities, if they are unknown, for example, we don't know the data, but what we said we want to find a data whose second order derivative is constant, and constant value must be equal to small a, for example. So according to the forward difference operator, this is the equation that reflect discretely exactly the condition that we have imposed. Discretely, that's the important point, because if it's not discrete, so I can express the same thing other way as well. Because what we want to say, that we want to say second order derivative is constant. So if the variable is continuous, it's not discrete, then I should not use difference equation. In this case, what should I use? I want to say DAVA2 of DAVA x is constant, or a whatever. So in this case, because variable is continuous, I can use differential equation concept. But here in our case, the variables are discrete. They are only defined at discrete points. So for discrete, we have a discrete approximation of derivative. So we did that, and we end up with the equation that represent data whose second order derivative is constant and is equal to a small amount of a. So this is just in one example. In this way, you can construct different rules that define a certain equation on a discrete data, and that equation is basically is called difference equation. So we can see here we are having a differences involving of a discrete data set with reference to the independent variable. And independent variable here is basically x, but it's not visible because we have converted everything into the form of indices. So I hope this point is clear to all of you, that whenever we want to discuss a difference equation, so what we want to say, basically we want to represent our data in a discrete form in such a way that there are some differences involved and in the form of equation. So that equation is called difference equation. Discrete data is important. The key points are discrete data is important. That's the main point. If it is continuous, we will not discuss with difference. We will discuss this as a differential equation, which we already learned. So this is the example. Sometimes we have a mathematical problem. We develop our equation. Sometimes we just observe something and we made our equation. For example, if I said to you, in fact, it's not new to you, you just need to go back little bit back, let's say 3 4 years back, when you are in a second year, you learn something called arithmetic series. uh, yeah, it is called arithmetic series. Arithmetic, yes, arithmetic, yes, arithmetic series, sequence. And that sequence has the sequence has something very special. If you remember, in arithmetic sequence, the sequence says if the first value is a, for example, this a has nothing to do with this a, we are discussing something different. Rather than using a, let's say a, and the other value is a plus d, and then other value is a plus 2d, and so on. So that sequence has a common difference, constant difference, common term. If I take two consecutive from these two and I compute this difference, so I will get a fixed difference, which is in this case is t. This is called arithmetic sequence, AF. You can take any two consecutive sequence, you always get a sequence. So this is the rule. Rule is you need to find a sequence in such that if you take a difference of two consecutive terms, you always get a fixed value. So how we can relate this with a difference equation? Because these are also a discrete data. Sequence deals with the discrete data. So how we can do that? If you remember, you all have developed this formula, nth term formula you used to call it. The formula is something like T n a plus n minus 1 into d. If you remember that term, what does this do? If you put n1, you will get first term. If you put n2, you will get second term. If you put n3, you will get third term, and so on. So this is called nth term formula. So what this formula is basically doing here is nothing. It is the formula that generates this sequence. Okay. So what does this thing has to do with arithmetic? Because the first point is discrete data, so it could be connected with difference equation as well. How? Like that. So let's think about it. What does this means to us? For example, in arithmetic sequence, rule is common difference is same, or in arithmetic sequence. So still, let's consider there are three data sets. So data sets is defined like that: yi, okay, and then there is some value yi plus 1, and there is one value yi minus 1. Obviously these are the y values, so they are corresponding to certain x values as well, xi, yi, yi. So but we are not dealing with xi anymore, because that xi is represented by these I values, because these indexes represent, they are corresponding to certain independent variables. So now these are the values. Let's impose a definition of the arithmetic sequence. Arithmetic sequence says, if this is the sequence, then the consecutive term is this one. If this is the sequence member, then its consecutive term is this one. So if you compute the difference of the consecutive terms, it has to be the same. So let's see what are the consecutive terms we have. So here, if I want to compute the consecutive term, is this one backside. So the difference could be defined as yi minus yi minus 1. So this is the node I am here, and I computed its difference from its previous value, back value. So as per the definition of AM, that quantity must be equal to what? It must be equal to, if I compute, because this term has two consecutive values, this term and this term. So this must be equal to, if I compute the consecutive difference of this quantity. So arithmetic, if you still want to recall, you can do it like that. This is a in your arithmetic, this is a plus d, then this is a minus d. So if you compute difference, a minus d, you will get d, and if you compute a plus d minus a, you get d, and interlevel. So this is the equation that way. We have three data sets, and we define the arithmetic sequence rule. Rule says common difference. So as per the common difference, these two should be same. Now what we have now, because the data is discrete, if we try to simplify it, how we can do that? So when we want to solve it, we want to take the terms towards the same side. So it's up to us where we want to take it. Like say I will take all these terms to that side. It's up to us. So what we have now, yi plus 1 subscript yi subscript minus yi plus yi minus 1 subscript equal to what? 0. So if I collect all these terms, yi minus 2 times of yi plus yi minus 1 equal to 0. So what we have now? We have a difference equation. Why? Because this is the equation that involves the discrete differences of a variable. If, because this is the rule, that is the rule that says, if I can find out those values, three consecutive values, yi minus 1, yi plus 1, so these are the values who has a rule that is their consecutive difference are same. So this is an arithmetic equation in our case, difference equation. But at enter level, yeah, I mean at the lower level, we represent it very form. So if what we have to do in this topic, obviously we cannot solve this topic completely in today's lecture. What we have to do, student, we have to solve those difference equations. We have to solve, just like differential equation, you have to solve differential. Here we have to solve. But what does solve means here? It means that we have to find those data sets that satisfy this condition, but or any other data set. We have to find all these data set, but in the form of a function. In the form of a function, we will try to get a formula that can generate all those values which satisfy that difference equation. For example, if I can solve this equation, I will get a numbers that satisfy the condition that if I take the common difference, it will be the same, because I constructed this difference equation based on this definition. Similarly, if someone try to solve this difference equation and manage to solve it, that is, he will obtain the sequence that satisfies this difference equation, then what will he has? He has a set of data whose second order derivative is constant and is equal to a. We will verify it when we solve in later stage. So that is what difference equation do. So difference equation represent the discrete set of data sets, differences of the discrete set of data sets, and what we have to do, we have to solve it. So we have to find a sequence that generate the data set that satisfy those numbers. that rule. So here the rule is second order derivative should be constant. So if we can find out, we will have a sequence that second order is constant equal to a. Similarly, the rule is here is that the common difference is same with the consecutive terms. If we can find out, which we learned in the later stage, how we can solve it. So that means that we have a discrete set of rules that satisfy this equation, which means that if we have those equation, that will exactly satisfy this differential equation. So at the end, what we have to learn is how to solve difference equation. And what is difference equation? Nothing. It is just like a differential equation. Only difference is it it applied to a discrete data, not on the continuous data. And whenever we say data, there is some independent or dependent, and we have to deal with the accordingly. So here some topic related to the called difference equation. And and near the end of the session, I just developed some concept behind it, that what is the difference equation concept we have, and what does this represent. I gave you example of a arithmetic sequence, and I gave you example that arithmetic sequence has a criteria that it is a discrete set of data, and difference of the two consecutive values is always same. This is one of the definition. So if we try to formulate this in the form of equation, we always end up in a difference equation form. The reason behind is that difference equation is just like a differential equation. The only difference is here the variable involved are discrete in nature. Keep in mind, the only difference between the differential equation and the difference equation is that in difference equation, nature of the variable with respect to the independent variable, usually we represented in the form of index independent variable, is discrete. Okay, that's the main difference, the difference between the differential equation and indifference equation. Okay, so that's what we discussed in the last time. Difference equation appear in many application problems where the variable are discrete in nature. The target for us to classify them and to understand how we can solve it based on certain example. That is what our objective. So how we can define this, or how we can discuss this part. So in order to understand it further, let's switch to some example, uh, like this one. Let's start here. In fact, okay, so difference equation, as we all know, is an equation that involves the differences of a discrete variable. But how do we classify them, or how do we differentiate them? So the first thing that we have to discuss is linear. There is some concept that we have to understand. Terms is called, we have to discuss first order linear. I know that all these words you already heard in a difference equation. First order linear homogeneous difference equation. First order linear homogeneous difference equation. The word is, what is first order means here, because if we discuss something in a rough work, so we can recall it like, we can recall that if this is the differential equation, again keep in mind on my word differential equation, for example, then let's say equal to 0. So we said that this is second order, and the reason for differential equation to claim as a second order is that it involves second order derivatives. This is the reason. So in differential equation where y is continuously defined unknown y function, so we can say that it is a second order. So it is very easy for us to understand. So question is, And similarly, if this term is absent, then the equation is a first order. We call it first order because the highest derivative left is 1, so it is a first order derivative. But what does this order means in a difference equation? So idea is quite simple. For example, let's assume, and I hope that I do not need to recall few points like what does this index means. For example, if I said yi plus 1, or in books you can find k plus 1, just keep in mind I is the indexing. And I remember I gave you idea that I want to say that there exists some value yi, and this value is 1 unit ahead of it, that is plus h units. So again, just for connection, we have some space in our upper. So if I write somewhere yi, it means that I am talking about f of xi. That is, there is some function and I want to read it at discrete point xi, so whatever be the answer I get is called yi. But if I said yi plus 1, this means that I want to read this function xi, but by adding amount h in the data set. Similarly, if I have something called I minus 1, so I want to say I want to read any function which is not obviously given to us at the point xi minus h unit. Keep in mind that this h is subtracting from this whole term. Similarly, this is adding in this whole xi. Okay, but here whenever I write something like yi minus 1, so this is only dealing in the subscript. Okay, this is in the subscript. What I want to say is that y subscript I minus 1 is not same as saying yi minus 1. So they are not same, they are different thing. You are here, you want to say we have a subscript I minus 1, here you want to say there is a value yi and I want to subtract 1 from it. So these are two different things. Why I said this such a small thing, because I noticed in examination paper assessment that students make this mistake because of the writing or something, that they think I minus 1 is no. Keep in mind that this is the value, it's the magnitude, and this is just an index. This is the index, it has a subscript. Okay, so whenever I said yi plus 1, you can understand there exists some variable yi, and what I'm talking about is the value which is 1 unit ahead of it. So what equation we call it first order, equal to, for example, some number, let's say a, for example, constant, and yi. If you have a difference, first of all, why it is a difference equation, because we indexing represents that they are discrete. We have a data at yi and then we have a data at yi plus 1. We have no information available in between there, as like in a differential equation. In differential equation, we assume that there exists a continuous function so that we can find a solution throughout the domain, which is not like that. So yi is a point, and then we want to compute this solution at yi plus 1. So what does this mean? So if any equation in I can write down it different ways. I can write it down like that as well. yi plus 1 minus a times of yi is 0, or other way around, like a times of yi a is this quantity minus yi plus 1 equal to, number of ways can be expressed. The main point is all of them are called first order, and they are linear. They are linear because this coefficient is constant. This coefficient is constant. Like you can assume there is a number 4. For example, if the equation is written like that, yi plus 1, some variable equal to 3 times of yi. So I will call it first order linear difference. I have not explained why, how to distinguish whether it is a homogeneous or not, but it is a difference equation because the discrete variable. So question is when to say that it is first order, how to know it. Either one way is to just memorize it. The other way is, for example, if this is written to in front of you, which is quite different whatever be written on the top. Let's say yi plus 2 equal to a times of yi minus 1. So this is still first order. Now question is, sir, you said that this is the first order. how they don't look like the same. So is there any generic rule that we can apply to understand which whether it is a first order or not? Because this information is very easy, but it's very important as well. Because while writing a solution or formulating a solution, information about the order is very important. So question is, what is the difference between these two equations? This one is a standard form usually we use, and this one. In fact, I have said wrong. In books, you can find this index as well sometimes, like yi equal to a times of yi minus 1. So if someone has a little bit understanding about about the indexing, so can compare these three equation which I am making a box over around it. So if you look carefully, technically these are they all these box equation are trying to say the same thing. What they are saying, like the new value, that is the value that you are interested to find, is equal to a times of previous value. How I can say previous value? Because this index is I plus 1, which is means a value ahead of it based on the value yi. So I plus 1. So if this is the I index, then I plus 1 is just value ahead of it. Similarly, if you look to this equation, so it in first impression they don't look same, but let's understand the concept behind it. Concept is quite similar now. What does this equation is saying? It's saying I minus 1 equation is obtained, yi plus 2 value is equal to a times of yi minus 1. So if you try to find the connection between these two values, you will find out that the new value is still obtained based on the previous value only. Similarly here, new value, that is a new index value, is obtained based on the previous value only, yi. So whenever you have this relation that the new value or a next index value is obtained just based on the previous value. So this type of difference equation is first order. Okay, so now what does this means here? So if you look carefully, this is I. Okay, you want to compute I based on a value I minus 1, which is its previous value. If I want to move to I have to go through from I minus 1 to I plus 1. Similarly, if I want to move to I plus 1, I have to go through I to I plus 1. Similarly, if I want to move to, oh, sorry, there is one mistake, student. This is I plus 1. I plus 1. Sorry, kindly correct it. I will explain this again. Yi plus 2 equal to a times of yi plus 1, that is previous value. Okay, so in the terms of index, if I want to understand, I have some space there. So what I am saying, what I am trying to explain is that if there is any index I, obviously I is not index, it is some coordinate xi I want to refer, then the value ahead of it, that is I plus 1, and the value which is 1 unit back of it I minus 1, and the value which is 2 unit ahead of it I plus 2, and similarly a value which is 2 unit back of it I minus 2 is defined like that. So what does these all equations are trying to say? They have a similar fashion. What they are saying, they are saying yi plus the unknown solution at yi plus 1 is obtained based on the previous node yi. What does this is saying? Yi plus 2 solution can be obtained based on its previous node, because for at I plus 2, if I am standing at I plus 2, then the previous value is I plus 1 lower index. And what does this say? Similarly, if I am at a yi plus 1, then the previous value is yi minus 1. So all of them are trying to explain the same thing. The only thing is that application, at what node I am applying. Technically, all of them are saying the same thing, that the new value, that is a value ahead of it, can be obtained purely based on the previous value